Hi guys, this is a picture my son drew today. I thought we would start with that because I think it's cute. He was supposed to draw the different seasons, or no, not the different seasons, the different types of weather that happen in spring. So there's sun and clouds and rain and wind right here. Then he drew a house and some mountains and a tree. And there's like a little squirrel here. He thought his teacher might not see it, so he wrote squirrel. Anyway, I enjoyed it, so I thought you might as well. Okay, so if you felt good about what we did yesterday, today is not much different at all. So we are going to be finding the volume of pyramids and cones. So yesterday was prisms and cylinders. Today is pyramids and cones. So this is a pyramid, cone, and another pyramid. Okay, so the formula for a pyramid for volume is 1/3 BH. And again, remember that capital B stands for area of the base. So that capital B is not a number that you're going to find on your shape. It's something that you're going to need to calculate. Okay, so like if it's a triangle, you'll find the area of the triangle, 1/2 base times height. If it's a square, you'll do length times width. So capital B is something you're going to have to calculate. It is not a number you're going to find on your shape. Okay, and then for a cone, the volume is 1/3 pi r squared. So this was the formula for a cylinder yesterday. We're just putting the 1/3 in front of it. This was the formula for prism yesterday. We're just putting the 1/3 in front of it. So a pyramid is like 1/3 the volume of a prism, and a cone is 1/3 the volume of a cylinder. Okay, so let's just try our first one. So volume of this pyramid is going to be 1/3 BH. Okay, and since my base is a square, I'm going to calculate the area of that square by doing length times width. Okay, so let's copy down the 1/3. And then for capital B, we are doing length times width. So 16 times 16. Okay, and then we are going to do the height of the pyramid. The height is this right here, 15. Okay, this thing over here, this is called a slant height because it is basically the height of that slanted face. Okay, we don't need that for anything, not in this problem anyway. Okay, all right, so let's plug this into our calculator. Here's how I would do this in your calculator. I would go 16 times 16 times 15, hit enter, and then multiplying by 1/3 is the same thing. We are dividing by 3. So let's just take this number and divide it by 3. And we end up with 1,280. Okay, and then feet times feet times feet is feet cubed. So that is our final answer. And that's exact. There is no approximate answer because I didn't have any pi's or square roots or anything. Okay, let's move down to the next one. This one is kind of kicking it up a notch. It's a little bit more difficult. Okay, we're going to use the same formula. Okay, and our base, okay, the base of our pyramid is a square again. So we're still just going to do length times width. The problem is we actually don't know what the height is. It just says h right here. So I'm going to have to figure out that height. So notice there's this like yellow right triangle. Okay, this length right here, this is from the center out to the edge. So if this entire thing is 40, from the center out to the edge would be 20. So 20 squared plus h squared is going to give us 25 squared. And they kind of pulled that out right here so you can see it better. 20 on the bottom, okay, 25 on the hypotenuse, and then this is h. So we're going to, over here to the side, we're going to go h squared plus 20 squared equals 25 squared. So that's h squared plus 400 equals 625. And then we'll subtract 400 from both sides. And we get h squared equals 225. And then we'll take the square root, and we'll take the square root. And we get h equals 15. So the height, this height right here, is 15. Okay? So now we can plug everything into our formula. Okay, the height is 15. So we'll plug that in for height. Okay, remember for capital B, for capital B, we are going to do the area of the base. So the area of the square, length times width. So length of the square is 40. Width of the square would also be 40. You get to assume that the bases are regular unless they tell you otherwise. So you get to assume this is a square. Okay, that's something our book tells us. I didn't write it down here on the notes, but I'm telling you. You get to assume that the base is regular unless they tell you otherwise. So if it's 40 here, it's 40 here. Okay, we're going to enter this in our calculator just like we did the last one. So we're going to go, let me zoom out just a little bit. We're going to go 40 times 15. Hit enter. And then we need to divide by 3. And we get 8,000 feet cubed. Okay? On the next one, this one is a cone. So our volume will be 1/3 pi r squared h. Okay? Our radius from the center out to the edge, our radius is 5. And it has to be squared. And then the height, again, we don't know. So we're going to have to figure out that height. We're going to do it the same way we just did it on the last problem. A squared plus b squared equals c squared. So h squared, height squared, plus 5 squared equals 13 squared. The Pythagorean theorem. Okay, so that's h squared plus 25 equals 169. And then we'll subtract 25 from both sides. And we get h squared equals 144. And then we'll take the square root of both sides. And we get h equals 12. Okay? So this is 12 meters. And we'll plug that in for height. Okay? Now, in our calculator, we're going to do 5 squared times 12. So 5 squared times 12. And we get 300. And then we're going to divide that by 3. So we get 100 pi. Meters squared times another meter would give us meters cubed. Okay? All of our units will be cubed because we're talking about volume. Okay? Whenever we're doing volume, the units are cubed. So basically what that means, again, volume is like how much water could I fill up this cone with? And we would measure the water in cubic units. Okay? So this basically means this many cubes would fit in here. Okay? And those cubes would be a meter by a meter by a meter. Okay. Let's flip over to the back. We have one more. Oops, mine's on another sheet. Okay, so this last one is the most difficult one. But we can do it. Okay, so this is a pyramid. So volume is 1/3 BH. Okay, our base is a triangle this time. The base of our pyramid is a triangle. So to find its area, we're going to do 1/2 base times height. One more time, remember that capital B means area of the base. So area of this triangle. And we find area by doing 1/2 base times height for a triangle. Okay. I already know the height of my pyramid. It is this red dotted line here, 15 centimeters. So I'm going to go ahead and write that in for the height, because I already know that. But I'm going to need to find the area of that shaded base, okay? And I think it's too hard to like figure it out when it's a part of this big shape. So I'm just going to redraw my base over here. Okay, my base is a triangle. It is an equilateral base, or a regular base, meaning if one side is 12 centimeters, all the sides are 12 centimeters. Okay? Also, equilateral triangles always have 3 60-degree angles. Okay, and then I'm going to drop down a height. Height has to be perpendicular to the base. Okay, what that does is it split that 60 into 30 and 30. So I have a 30, 60, 90 triangle and a 30, 60, 90 triangle. If this entire base is 12, this is 6. Okay, and in a 30, 60, 90 triangle, this is your n, this is 2 times n, and then this side, right here, is your n square root 3. N, 2n, n square root 3 right here. Okay, so now that I know all of that information, I can find the area of that triangle, the area of that base. Okay, remember, all I did is I took this shaded base here and I redrew it over here so that I could more easily label it. Okay, so the area of that base is 1/2 the base of the triangle times the height of the triangle. 6 square root 3. Okay, now here's what I would do. I am going to take, zoom out a second, 12 times 6 times 15. 12 times 6 times 15, and hit enter. So 12 times 6 times 15. Okay, and then I need to divide by 2 and hit enter. And then I also need to divide by 3 and hit enter. And we get 180. And then we have to put the square root 3 next to it. Centimeters times centimeters times centimeters is centimeters cubed. This would be our exact answer because we have not rounded anything. Okay, if we want to figure out what that is approximately, take your 180 and multiply it by the square root of 3. And we get approximately 311.8 centimeters cubed. Okay, that is it for today's notes. Remember, if you need help with your homework, I'm going to be on Zoom at 3 o'clock. I'd like to see you guys there. I had one person join me yesterday. I'd like to get more of you to join me. It's like free help, okay? So free time to get that homework done. And if you have questions about other things, we can go over that as well. So hope to see you guys at 3 o'clock. Alrighty, bye.